About 68 million years ago, one of the most famous animals in Earth's history appeared in western North America. Tyrannosaurus rex lived during the Late Cretaceous Period and was among the last giant dinosaurs before the mass extinction that happened about 66 million years ago. It could grow to more than 12 meters in length, stand about 4 meters tall at the hips, and weigh several tons. It had powerful jaws with thick, sharp teeth that could crush bone, strong legs built for walking and chasing prey, and small but muscular arms with 2 claws. The rise of large tyrannosaur species is one of the most important parts of dinosaur history. These powerful meat-eating animals did not begin as giant hunters. Their earliest ancestors were much smaller and lived among many other predators that ruled the land. Over a very long period of time, their bodies slowly changed as new generations appeared. Small changes in size, strength, movement, hunting ability, and senses gradually produced some of the largest and most powerful land predators that have ever lived. This process took many millions of years and happened as the world itself continued to change. Continents drifted apart, climates changed, forests expanded and disappeared, sea levels rose and fell, and many different kinds of animals appeared while others vanished. Every change in the environment created new challenges and new chances for survival. Tyrannosaurs slowly adapted to these changing conditions until some members of the family reached enormous sizes. The earliest members of the Tyrannosaur family appeared during the Middle Jurassic period. At that time, they were small animals that usually measured only a few meters in length. They were light in weight, had long legs, sharp claws, and long tails that helped them keep their balance while running. Their arms were much longer than those of their later giant relatives and were useful for catching prey. Their heads were also much smaller than those of the giant tyrannosaurs that lived much later. Although they already had many features that would later become common among tyrannosaurs, they were still very different from the huge animals that people know today. These early tyrannosaurs lived in a world filled with many kinds of predators. Large allosauroids, megalosaurs, and several other groups of meat-eating dinosaurs dominated many regions. These larger hunters often occupied the highest position among land predators. Small tyrannosaurs probably hunted smaller animals and avoided direct competition with the biggest hunters. They likely fed on small dinosaurs, early mammals, lizards, insects, and other animals that they could catch. Their smaller bodies allowed them to move quickly through forests and across open land in search of food. Over many millions of years, new tyrannosaur species continued to appear. Natural selection favored individuals that possessed useful traits for survival. Some had better eyesight. Others had stronger jaws, better hearing, or longer legs that allowed them to move more efficiently. These useful features were passed from parents to their young. As countless generations lived and died, the entire family slowly changed. No single generation suddenly became much larger than the one before it. Instead, body size increased little by little over an enormous stretch of time. The changing continents also played an important part in tyrannosaur evolution. During the Jurassic period, many land areas were still connected, allowing animals to spread across wide regions. As time passed, the continents slowly separated. Populations of tyrannosaurs became isolated from one another. When groups remained separated for very long periods, they followed different evolutionary paths. Some remained relatively small, while others slowly developed larger bodies and stronger skulls. Isolation allowed many different tyrannosaur species to appear in different parts of the northern continents. Climate also influenced the rise of larger tyrannosaurs. Temperatures, rainfall, and plant life changed many times throughout the age of dinosaurs. These environmental changes affected the animals that plant-eating dinosaurs depended upon. As forests expanded or grass-like plants became more common in certain places, large plant-eating dinosaurs also changed. New kinds of herbivores appeared and many grew to impressive sizes. Large predators needed enough food to survive, so the growth of large prey animals created opportunities for larger meat-eaters. Tyrannosaurs slowly evolved to take advantage of these food sources. One important reason that tyrannosaurs eventually became so large was the disappearance of other giant predator groups. Earlier in dinosaur history, large allosauroid predators occupied many ecosystems across the northern continents. These animals had ruled for millions of years. Later, many members of these older groups disappeared. The exact reasons are still being studied, but changing climates, changing habitats, competition, and other environmental pressures may all have played a part. As these older predators declined, empty ecological roles became available. Tyrannosaurs slowly expanded into these positions and eventually became the dominant large predators in many areas. As tyrannosaurs increased in size, many parts of their bodies changed together. Their skulls became much larger and much stronger. Thick bones supported powerful jaw muscles that could generate tremendous biting force. The bones of the skull were tightly connected, allowing the head to withstand powerful stresses while biting struggling prey. These changes allowed tyrannosaurs to attack larger animals than their smaller ancestors could manage. Their teeth also changed. Early tyrannosaurs possessed thinner teeth that were useful for cutting flesh. Later giant tyrannosaurs developed thicker teeth with rounded cross-sections. These teeth were extremely strong and less likely to break under heavy pressure. Deep grooves along the edges formed sharp cutting surfaces that sliced through flesh, while the thick shape resisted damage. Some teeth were almost the size of large bananas. New teeth continually grew throughout life, replacing broken or worn teeth whenever necessary. The neck also became stronger as body size increased. Large neck muscles helped support the heavy skull and allowed the head to move quickly during attacks. Thick neck bones provided strong attachment points for muscles and ligaments. Together, these structures gave giant tyrannosaurs excellent control over their heads while biting, pulling, and tearing flesh from prey animals. The legs of large tyrannosaurs remained one of their greatest strengths. Although they became much heavier than their ancestors, they still possessed long, powerful hind limbs that allowed efficient movement across long distances. Strong thigh muscles and large lower leg bones supported their great weight. Scientists believed that the largest adults were probably not extremely fast runners because of their massive bodies. However, they could likely walk efficiently for long periods and move quickly enough to capture many large herbivores. Their tails also became extremely important. A long, muscular tail balanced the heavy head and body while walking and turning. Large muscles attached to the tail helped power the hind legs with every step. Without such a heavy tail, maintaining balance would have been much more difficult for these enormous animals. One of the most unusual features of giant tyrannosaurs was their very small arms. Earlier members of the family had much longer arms, with 3 fingers. As body size increased, the arms gradually became shorter, while still remaining muscular. Most later giant tyrannosaurs possessed only 2 functional fingers. Although these arms looked tiny beside the enormous body, they were still quite strong. Scientists continue to study exactly how they were used. They may have helped hold struggling prey for a short time, assisted when rising from the ground, or served other purposes that are not fully understood. The senses of large tyrannosaurs became highly developed. Their eyesight was excellent. Their eyes faced forward, providing strong depth perception that helped judge distance accurately. This ability was especially useful when attacking moving prey. Large eye sockets suggest that vision played an important role in daily life. Good eyesight allowed them to detect movement over long distances and hunt more effectively. Their sense of smell became one of their greatest strengths. The parts of the brain responsible for processing smells were very large. Large openings within the skull housed powerful smell receptors. This keen sense of smell helped tyrannosaurs locate food across great distances. They could probably detect injured animals, dead carcasses, or prey hidden among vegetation. Their powerful noses may also have helped them recognize members of their own species. Hearing was also well developed. The structure of the inner ear suggests that tyrannosaurs could detect low-frequency sounds. These sounds travel long distances and may have helped individuals communicate across wide areas. Good hearing also allowed them to detect approaching animals even when they could not be seen. The brain of large tyrannosaurs showed important developments as well. Although dinosaur brains were generally much smaller than those of mammals of similar body size, tyrannosaurs possessed relatively large brains compared with many other dinosaurs. Brain regions connected with balance, movement, smell, and vision were especially well developed. These features supported effective hunting and efficient movement. As tyrannosaurs grew larger, their hunting methods probably changed. Small ancestors likely chased smaller prey that could be captured quickly. Giant species were capable of attacking very large herbivorous dinosaurs. A single powerful bite could cause severe injuries. Strong jaws crushed bones as well as flesh. Bite marks found on fossil bones show that tyrannosaurs frequently bit deeply into their prey. Some bones even preserve broken tyrannosaur teeth that became stuck during feeding. Scientists continue to study whether giant tyrannosaurs mainly hunted live prey or often fed on animals that had already died. Evidence suggests that they probably did both whenever opportunities appeared. Their strong sense of smell would have helped them locate carcasses over long distances, while their powerful bodies allowed them to hunt large living animals when conditions were favorable. Many modern meat-eating animals will also combine hunting with scavenging whenever possible, because both activities provide food. Young tyrannosaurs probably lived very different lives from adults. Newly hatched young were small enough to avoid many dangers by hiding amongst vegetation. As they grew, their bodies changed rapidly. Juveniles had longer legs relative to body size and lighter builds than fully grown adults. These features suggest that young tyrannosaurs were faster and more agile. They probably hunted smaller prey while avoiding direct competition with giant adults. As they continued growing, their skulls became deeper, their jaws stronger, and their bodies heavier. This gradual change allowed individuals of different ages to use different food sources. Younger animals hunted smaller prey, while adults focused on much larger animals. This reduced competition within the same species because individuals at different ages relied on different kinds of food. Growth studies based on fossil bones have revealed that giant tyrannosaurs experienced periods of especially rapid growth. During these years, body mass increased quickly. Growth rings preserved inside fossil bones allow scientists to estimate the age of individuals when they died. These rings are somewhat similar to those found in tree trunks. By studying them carefully, researchers have learned that many tyrannosaurs grew rapidly during their teenage years before reaching full adult size. Not every individual reached maximum size. Some died while still young because of disease, injury, starvation, drought, flooding, or attacks from other predators. Fossils preserve evidence of broken bones, healed injuries, infections, and diseases that affected tyrannosaurs during life. Some individuals survived severe injuries that would have required long recovery periods. Fossils preserve evidence of broken bones, healed injuries, infections, and diseases that affected tyrannosaurs during life. Some individuals survived severe injuries that would have required long recovery periods. Large tyrannosaurs shared their environment with many other dinosaurs. Huge plant eaters such as horned dinosaurs, duck-billed dinosaurs, armored dinosaurs, dome-headed dinosaurs, and giant long-necked species lived in different regions depending on the time and place. Smaller meat-eating dinosaurs also continued to exist alongside tyrannosaurs. Each species occupied its own place within the ecosystem. The ecosystems where giant tyrannosaurs lived were rich and diverse. Rivers crossed broad floodplains, forests covered large areas, swamps, lakes, and coastal environments supported countless plants and animals. Ferns, conifers, flowering plants, and many other kinds of vegetation provided food for plant eaters. These herbivores, in turn, supported populations of large predators. Seasonal changes also influenced daily life. Some regions experienced wet seasons followed by dry periods. Rivers sometimes flooded large areas before shrinking again. Animals had to adapt to changing food supplies and shifting water sources. Tyrannosaurs likely traveled across wide territories while searching for prey and suitable living conditions. Fossils discovered across parts of Asia and North America reveal that many different large tyrannosaur species appeared during the Late Cretaceous Period. Each species possessed its own unique features while sharing many characteristics with close relatives. Some had taller skulls, others had different horn shapes above the eyes, while tooth shape and body proportions also varied. These differences help scientists identify separate species even when they belong to the same family. One important Asian tyrannosaur was Tarbosaurus. It lived in what is now Mongolia and nearby regions. It closely resembled later North American giant tyrannosaurs, but possessed several differences in skull structure and body proportions. Tarbosaurus became one of the largest predators in its environment and hunted the large herbivorous dinosaurs living alongside it. Other important Asian tyrannosaurs included Zhuchengtyrannus and several related species discovered during recent decades. New fossil discoveries continue to expand scientific knowledge about tyrannosaur diversity. Each new skeleton helps researchers better understand how these animals evolved across different regions. North America became home to several impressive giant tyrannosaurs as well. Daspletosaurus appeared before the arrival of Tyrannosaurus. It possessed a deep, powerful skull, thick teeth, and strong jaws. Fossils suggest that it hunted large horned dinosaurs and duck-billed dinosaurs living in its environment. Different species of Daspletosaurus lived across western North America over long periods. Another important giant was Gorgosaurus. Although somewhat lighter than later Tyrannosaurus, it still reached impressive sizes and became one of the leading predators within its ecosystem. Fossil discoveries provide valuable information about growth, development, injuries, and feeding behavior. Albertosaurus also became one of the best-known tyrannosaurs. Numerous skeletons have been discovered, including sites where many individuals were found together. These discoveries have led scientists to investigate whether tyrannosaurs sometimes lived or traveled in groups. The evidence remains uncertain, but such fossil sites continue to provide important clues about their behavior. The largest and most famous member of the family eventually appeared near the end of the Cretaceous period. Tyrannosaurus rex, represented the peak of tyrannosaur evolution in terms of size, jaw strength, and skull development. Adults could reach enormous lengths and weights. Their massive skull housed one of the strongest bite forces ever measured for a land animal. Thick, powerful teeth crushed bone with remarkable efficiency. Every part of the body reflected millions of years of gradual evolutionary change. The success of giant tyrannosaurs depended on many different factors working together. Large body size alone could not guarantee survival. Strong senses, efficient movement, rapid growth, powerful jaws, healthy ecosystems, and abundant prey all contributed to their success. If any one of these important conditions had changed significantly, the history of tyrannosaurs might have followed a different path. Scientists continue discovering new tyrannosaur fossils almost every year. Some discoveries include nearly complete skeletons, while others consist of isolated teeth, bones, footprints, or fragments. Every fossil adds another piece to the story of tyrannosaur evolution. Modern technology allows researchers to examine fossils using advanced scanning equipment that reveals internal structures without damaging the bones. Bone tissue provides valuable information about growth and health. Scientists cut extremely thin sections from damaged or already broken fossil bones and examine them under microscopes. Growth rings, blood vessel patterns, and bone structure reveal how quickly individuals grew, how old they became, and whether they suffered illnesses or injuries during life. Computer models can also help scientists study giant tyrannosaurs. Digital skeletons allow researchers to estimate body weight, walking speed, muscle size, and bite force. These models continue improving as new fossils become available. Although some uncertainty remains, they provide valuable insights into how these enormous predators lived. Footprints also contribute important information. Fossil tracks reveal walking direction, stride length, and sometimes the speed of movement. Some trackways preserve evidence of several dinosaurs moving across the same ancient landscape. These footprints provide direct evidence of animal movement that skeletons alone cannot show. Bite marks preserved on fossil bones also tell an important story. Some prey animals survived attacks and healed afterward, leaving damaged bones with clear signs of recovery. Other fossils show feeding marks left after death. Broken tyrannosaur teeth preserved inside prey bones demonstrate just how powerful their bites could be. The rise of large tyrannosaur species was not the result of one single event. It happened through a very long series of gradual evolutionary changes that affected body size, skull strength, teeth, muscles, senses, growth, movement, and behaviour. Every generation inherited useful features from the one before it, while small new changes slowly accumulated. Environmental changes, shifting continents, changing climates, the disappearance of older predators, and the spread of large plant-eating dinosaurs all created conditions that favoured the growth of increasingly larger tyrannosaurs. By the final part of the Age of Dinosaurs, giant tyrannosaurs had become the dominant predators across much of the northern continents. Their enormous bodies, powerful jaws, excellent senses, efficient movement, and advanced hunting abilities made them highly successful within the ecosystems where they lived. Fossils preserved in rocks across Asia and North America continue to reveal new details about their biology, behaviour, growth, health, and evolution, allowing scientists to develop an increasingly detailed understanding of how these remarkable, giant predators gradually rose from small ancestors into some of the largest meat-eating land animals that ever lived. Tyrannosaurus rex was one of the largest meat-eating land animals that ever lived. Its body was built for strength, power, and survival. Every part of its body had a purpose that helped it live as a top predator during the final part of the age of the dinosaurs. Scientists have learned about its body by studying many fossil bones that have been discovered over many years. These fossils have helped researchers understand how this animal stood, moved, hunted, grew, and lived. Even though soft parts such as skin, muscles, and internal organs are rarely preserved, the bones provide a great amount of information about its appearance and physical features. An adult Tyrannosaurus rex had a very large body that stretched to a length of about 40 feet from the tip of its nose to the end of its tail. It stood around 12 to 13 feet tall at the hips. Its body weight reached about 7 to 9 tons in many adults, although some very large individuals may have been even heavier. Its size alone made it one of the biggest land predators that ever existed. The skull of Tyrannosaurus rex was one of its most remarkable features. It was very large and extremely strong. The skull could grow to more than 5 feet in length in the biggest adults. Unlike the skulls of many other meat-eating dinosaurs, the skull of Tyrannosaurus rex was built to resist powerful forces produced during biting. The bones of the skull were tightly connected to reduce movement between them. This made the entire head much stronger when crushing flesh and bone. Large openings were present in the skull. These openings reduced the total weight of the head while still keeping it strong. They also provided space for muscles, blood vessels, nerves, and other soft tissues. The arrangement of these openings allowed the head to remain powerful without becoming too heavy for the neck to support. The jaws of Tyrannosaurus rex were deep and thick. They contained rows of large teeth that were designed for gripping and tearing flesh. Unlike the thin blade-like teeth found in many other meat-eating dinosaurs, the teeth of Tyrannosaurus rex were thick, rounded, and very strong. This shape reduced the chance that the teeth would break while biting into large animals or crushing bones. An adult Tyrannosaurus rex usually had about 60 teeth, although the exact number could vary slightly from one individual to another. The teeth near the front of the upper jaw had a different shape from those farther back. The front teeth were useful for gripping prey firmly, while the larger side teeth helped tear away pieces of flesh and crush bones. Each tooth had tiny saw-like edges called serrations. These small edges helped cut through meat more effectively. When Tyrannosaurus rex bit into an animal, the serrated teeth sliced through skin, muscle, and other tissues, while the enormous strength of the jaws forced the teeth deep into the body. The teeth were constantly replaced throughout the dinosaur's life. If a tooth broke or fell out, another tooth slowly grew beneath it. This replacement process ensured that the animal continued to have effective teeth for hunting and feeding even after losing some through normal use. The bite of Tyrannosaurus rex was among the strongest ever measured for a land animal. Scientists studying the skull and jaw muscles believe that its bite force reached many thousands of pounds of pressure. This tremendous force allowed it to crush bones as well as tear through thick flesh. Fossil bones from other dinosaurs often show deep bite marks that match the teeth of Tyrannosaurus rex. Some bones were even broken and crushed by its powerful jaws. The lower jaw was also heavily built. Strong jaw muscles attached to the back of the skull and the lower jaw, giving tremendous force during biting. The joints connecting the jaws allowed them to open wide enough to bite into very large animals. The nose of Tyrannosaurus rex was long and broad. The nasal bones running along the top of the snout were fused together into a solid structure. This fusion strengthened the front part of the skull and helped it withstand the forces created during powerful bites. The nostrils were located near the front of the snout. Air entered through these openings and passed into the breathing passages. Scientists believe Tyrannosaurus rex had a highly developed sense of smell. The parts of the brain connected with smelling were very large. This suggests that it could detect odours over long distances. A strong sense of smell would have helped it locate prey, find carcasses, recognise members of its own species, and detect possible dangers. The eyes were placed on the sides of the head but faced slightly forward. This arrangement gave Tyrannosaurus rex an area where the fields of vision from both eyes overlapped. This overlapping vision helped provide depth perception, making it easier to judge distances accurately while approaching prey or moving through its environment. The eyes themselves were probably quite large. Large eyes usually gather more light, helping animals see better under different lighting conditions. Good eyesight would have been important for finding prey and watching the surrounding area. Protective rings of bone known as sclerotic rings supported the eyeballs. These rings are found in many dinosaurs and helped maintain the shape of the eyes. The ears did not have external flaps like those of many mammals today. Instead, sound entered through openings located behind the eyes. Studies suggest Tyrannosaurus rex could hear low-frequency sounds especially well. Such sounds travel long distances and may have helped individuals communicate or detect movement. The brain of Tyrannosaurus rex was not especially large compared with modern mammals, but it was fairly advanced for a dinosaur of its size. Parts responsible for balance, vision, smell, and movement were well developed. These features suggest that Tyrannosaurus rex possessed good coordination and effective control over its body. The neck was short, thick, and extremely muscular. It supported the heavy skull while allowing the head to move in different directions. Powerful neck muscles helped lift the head after biting into prey and allowed strong pulling movements when tearing flesh from carcasses. The neck bones were large and strong. They had spaces inside that reduced their weight without greatly reducing their strength. This made it easier to support the enormous head while maintaining flexibility. The body was deep and broad. The chest contained the lungs, heart, and other internal organs. Large ribs curved around the chest to protect these organs while providing attachment points for muscles. The backbone extended from the neck through the body and into the tail, each vertebra connected with the next through joints that allowed movement while maintaining strength. Strong ligaments and muscles running along the backbone helped support the body and stabilize movement. The shoulders supported the relatively small front limbs. Although the arms were tiny compared with the rest of the body, they were not weak. The bones were thick and heavily built, showing that they supported strong muscles. Each arm had only 2 fingers. Each finger ended in a large, sharply curved claw. These claws were made of bone covered during life by hard keratin. The claws were sharp enough to grip objects or hold prey. Scientists have debated the exact purpose of the arms for many years. They may have helped grip struggling prey, assisted the dinosaur while rising from the ground, or played a role during mating. Whatever their purpose, the arms were clearly muscular despite their short length. The upper arm bone was short but thick. The forearm was also compact and strong. Large muscle attachment areas on these bones show that the muscles controlling the arms were well developed. The hands faced inward rather than downward. This arrangement allowed the claws to grasp toward each other instead of pointing directly at the ground. The legs were among the strongest parts of the body. Each hind limb was long, muscular, and capable of supporting the enormous weight of the animal. The thigh bone was massive and connected to equally powerful lower leg bones. The muscles surrounding the hips and thighs generated the force needed for walking and running. Large attachment points on the bones show that these muscles were exceptionally strong. The feet had 3 main weight-bearing toes. A smaller toe was located slightly higher on the foot and usually did not touch the ground while walking. Each main toe ended in a large claw that helped provide grip on different surfaces. The foot bones distributed the animal's great weight across the ground. Thick pads beneath the feet probably helped absorb shock while walking. The hips were extremely broad and powerful. Large hip bones supported the body's weight and served as attachment points for many muscles controlling movement. The hip structure also protected internal organs located in the lower body. The pelvis consisted of several fused bones that formed a strong framework connecting the backbone with the legs. This framework transferred the body's weight efficiently into the hind limbs. The tail of Tyrannosaurus rex was very long and heavy. It contained many vertebrae extending far behind the body. Large muscles attached to the base of the tail and connected with the hind limbs. These muscles generated much of the force needed for walking and running. The tail also acted as a balance structure. Since the head was extremely heavy, the long tail helped keep the body's center of gravity near the hips. This balance allowed Tyrannosaurus rex to stand on its hind legs without falling forward. The tail gradually became narrower toward the tip. Although the end of the tail contained smaller bones, strong ligaments helped keep the tail fairly stiff while still allowing limited movement. The skin of Tyrannosaurus rex is not completely known, because only a few skin impressions have been discovered. These impressions suggest that much of the body was covered with small scales. The scales varied in size and shape depending on the part of the body. Some areas had tiny pebble-like scales packed closely together. Other areas showed larger scales surrounded by smaller ones. These different patterns may have strengthened the skin while allowing flexibility during movement. Scientists continue to study whether some parts of the body carried simple feathers. Close relatives of Tyrannosaurus rex preserved in fossils show evidence of feathers, especially smaller species that lived earlier. Some researchers think young Tyrannosaurus rex may have possessed patches of simple feathers for warmth, while adults may have had fewer feathers because their large bodies retained heat more effectively. Evidence remains limited, so the exact amount of feather covering is still being investigated. The color of Tyrannosaurus rex remains unknown because skin pigments are rarely preserved in fossils. Scientists cannot state with certainty whether it was green, brown, grey, black, reddish, or another color. Its body may have included different shades across various regions, but fossil evidence has not yet provided definite answers. The muscles of Tyrannosaurus rex covered much of its skeleton. Thick muscles surrounded the neck, shoulders, hips, thighs, and tail. These muscles provided strength for movement, biting, feeding, and maintaining posture. The chest muscles helped move the front limbs, while the massive leg muscles powered walking and other movements. Strong muscles attached along the tail contributed greatly to the movement of the hind legs. The bones of Tyrannosaurus rex were not solid throughout. Many contained internal spaces that reduced weight while maintaining strength. This feature helped the animal carry its enormous size more efficiently. The joints connecting the bones allowed movement while limiting motions that could damage the skeleton. Cartilage covered the ends of bones, reducing friction as the joints moved. The ribs protected the lungs and heart. Some ribs connected with structures that helped strengthen the chest. The breathing system probably shared several features with modern birds, including air sacs connected to the lungs. These air sacs may have improved breathing efficiency and reduced the weight of parts of the skeleton. The lungs were likely very effective at supplying oxygen to the body's tissues. A large predator with powerful muscles required a constant supply of oxygen during movement and feeding. The heart itself has never been found because soft tissues rarely fossilize. Scientists believe it was large enough to pump blood throughout the enormous body. The digestive system included a large stomach capable of processing large amounts of meat. Strong digestive acids likely helped break down flesh, while the crushed bones swallowed during feeding provided minerals. The tongue probably remained attached to the floor of the mouth rather than moving freely like the tongue of many mammals. This feature is common in living reptiles and birds. The throat was wide enough to swallow large pieces of meat. Tyrannosaurus rex probably did not chew food in the same way that mammals do. Instead, it tore off large chunks with its teeth and swallowed them. The skeleton became stronger as the animal matured. Young individuals had slimmer bodies, longer legs in proportion to their size, and lighter skulls. As they grew older, the skull thickened, the body became heavier, and the bones became stronger. Bone studies show that growth occurred rapidly during certain periods of life. Layers inside the bones record yearly growth, allowing scientists to estimate the age of individual animals. Young Tyrannosaurus rex looked different from fully grown adults. Juveniles had narrower skulls, thinner teeth, and relatively longer legs. These differences suggest that younger individuals may have hunted smaller prey before reaching full adult size. As adulthood approached, the head became broader and deeper, the jaw muscles became larger, and the teeth became thicker and stronger. The body gradually developed the powerful shape seen in adult fossils. The bone surface changed during growth. Young animals usually had smoother bone surfaces, while older adults often showed rougher areas where muscles and ligaments attached more strongly. Some adult skeletons show healed injuries. Broken ribs, damaged jaws, infected teeth and injured feet reveal that Tyrannosaurus rex could survive serious wounds. Bone tissue slowly repaired these injuries over time. Some skulls contain holes and rough surfaces that may have resulted from infections or injuries caused during encounters with prey or other Tyrannosaurus rex individuals. These healed wounds show that many animals lived long enough for damaged bones to recover. The claws on both the hands and feet were covered by hard outer sheaths during life. These sheaths extended beyond the bone itself, making the claws slightly longer than fossil bones alone suggest. The legs ended in flexible joints that allowed efficient walking. Although scientists continue studying its maximum speed, the body structure clearly shows that it relied on strong hind limbs for movement. The backbone contained many vertebrae connected by strong ligaments. These structures stabilized the body while allowing enough flexibility for turning and maintaining balance. The shoulder blades lay along the sides of the rib cage. They supported muscles that controlled the arms and helped stabilize the front part of the body. The collarbone found in many mammals was absent. Instead, other bones and muscles provided support for the shoulders. The wrists allowed only limited movement. This restriction kept the hands facing inward, strengthening their ability to grip. The ankle bones formed a stable joint capable of supporting tremendous weight. Strong tendons connected muscles with the bones, allowing efficient transfer of force during movement. The tail muscles attached firmly to projections on the vertebrae. These muscle attachments are clearly visible on fossil bones and indicate the importance of the tail in locomotion. The surface of the skull contained many small openings through which blood vessels and nerves passed. These openings supplied the skin and tissues covering the head. Sensitive nerves around the jaws and snout may have helped Tyrannosaurus rex detect pressure and touch while biting or feeding. Similar sensory structures exist in living reptiles today. The inside of the skull has been studied using modern scanning technology. Digital models allow scientists to estimate the size and shape of the brain without damaging valuable fossils. These studies provide information about hearing, vision, smell, and balance. The inner ear structure suggests that Tyrannosaurus rex possessed good balance. Maintaining balance was especially important because of its enormous head and long tail. The spinal cord passed through the center of the vertebrae, carrying signals between the brain and the rest of the body. Nerves branching from the spinal cord controlled muscles and transmitted information from the skin and other tissues. Blood vessels supplied oxygen and nutrients throughout the body. Large arteries carried blood from the heart, while veins returned blood to be pumped again. The bones themselves contained living tissue during life. Blood vessels entered the bones through tiny openings, supplying nutrients needed for growth and repair. The teeth were anchored deeply within the jaw bones. Strong roots held each tooth securely during biting. Replacement teeth slowly developed beneath existing teeth before moving upward to replace worn or damaged ones. The jaw muscles filled large spaces behind the skull. These muscles contracted with tremendous force whenever the dinosaur bit into food. The cheeks probably did not resemble the fleshy cheeks of mammals. The mouth likely opened widely, exposing much of the teeth when feeding. The lower jaw could withstand repeated heavy bites because of its thick construction and reinforced joints. The neck muscles attached to large projections on the back of the skull. These attachment areas show that the head could be lifted, lowered, and turned with considerable strength. The skin around the neck probably formed folds that allowed movement without stretching too tightly. The body shape of Tyrannosaurus rex placed most of its weight over the hips. This arrangement reduced stress on the spine and allowed the hind limbs to support the body efficiently. The chest expanded and contracted during breathing. Movements of the ribs and other breathing muscles helped draw air into the lungs and push it back out. The body temperature of Tyrannosaurus rex remains an active area of scientific research. Many scientists believe it maintained a relatively stable internal temperature through a combination of its metabolism and its large body size. The large liver, kidneys, intestines, and other internal organs have not been preserved directly, but their presence can be inferred from the anatomy of living reptiles and birds and from the available fossil evidence. The entire body of Tyrannosaurus rex reflected millions of years of evolution within the Tyrannosaur family. Each bone, joint, muscle attachment, tooth and physical feature contributed to an animal capable of surviving in the environments of Western North America during the final part of the Late Cretaceous Period. Fossil discoveries continue to provide new details about its body structure, and each new skeleton helps scientists improve their understanding of the physical appearance, growth, anatomy, movement, and daily life of this remarkable dinosaur. Growth, development, and life stages are important parts of the story of Tyrannosaurus rex because they help scientists understand how this famous dinosaur changed from the moment it hatched until the end of its life. Every living animal begins as a very small young individual and then passes through many stages before becoming fully grown. Tyrannosaurus rex followed this same pattern, although its journey from a tiny hatchling to one of the largest meat-eating land animals ever known took many years. During this time, its body changed in size, shape, strength, and behaviour. Each stage brought new challenges and new abilities. Fossils collected over many years have allowed scientists to study these changes in great detail. By examining bones from individuals of different ages, researchers have built a clearer picture of how Tyrannosaurus rex grew throughout its life. The story of growth in Tyrannosaurus rex started inside an egg. Like other known dinosaurs, it reproduced by laying eggs rather than giving birth to live young. No egg that can be confirmed with complete certainty as belonging to Tyrannosaurus rex has yet been discovered, but fossils from closely related dinosaurs show that eggs were an important part of the life cycle. A female Tyrannosaurus rex would have produced eggs with strong shells that protected the developing young. Inside each egg, a growing embryo slowly formed its bones, muscles, organs, skin, eyes, and other body parts. The embryo received food from the yolk stored inside the egg until it was ready to hatch. The eggs were probably placed in a nest built on the ground. Scientists continue to study how Tyrannosaurus rex may have cared for its eggs. Some closely related dinosaurs are believed to have watched over their nests, protecting them from smaller predators that could steal or eat the eggs. Since many dinosaurs showed some level of parental care, it is possible that Tyrannosaurus rex also guarded its nest for at least part of the incubation period. The exact amount of care remains uncertain because direct fossil evidence has not yet been found. While the embryos developed inside their eggs, their bones slowly became stronger. The first bones were made mostly of soft cartilage before turning into hard bone tissue. Blood vessels carried nutrients throughout the growing body. Tiny muscles formed and connected to the skeleton. Teeth also began developing inside the jaws before the hatchlings even emerged from the eggs. By the time hatching arrived, each young Tyrannosaurus rex already possessed many of the body features needed for survival. Hatching was one of the most dangerous moments in the life of a young Tyrannosaurus rex. The hatchling had to break through the eggshell using a special structure that helped crack the shell. Once outside, it entered a world filled with many dangers. Small meat-eating dinosaurs, larger predators, and even natural events such as storms could threaten its survival. Only a small number of hatchlings probably lived long enough to become adults. A newly hatched Tyrannosaurus rex was much smaller than the enormous adults known from museums today. It may have weighed only a few kilograms and stood low to the ground. Its head was much smaller, its legs were thinner, and its body was covered by skin that may have included patches of simple feathers during the earliest part of life. Some scientists believe young Tyrannosaurus rex had more feather-like covering than adults because feathers could have helped young animals keep warm. Direct evidence remains limited, so this idea continues to be studied. The hatchling needed food almost immediately after leaving the egg. Its sharp little teeth allowed it to bite small animals and tear soft flesh. Insects, tiny reptiles, mammals, amphibians, and other small creatures may have formed part of its early diet. It probably hunted prey that matched its own small size because it lacked the strength needed to attack larger animals. Growth during the first years of life was steady. Every meal provided energy that allowed bones to become longer, muscles to grow larger, and internal organs to develop further. Bone cells divided rapidly, adding new layers to the skeleton. Scientists can sometimes see growth rings inside fossil bones. These rings are somewhat similar to those found inside tree trunks because they provide clues about yearly growth. By counting and studying these rings, researchers estimate the ages of individual Tyrannosaurus rex specimens and learn how quickly they grew. The bones of young Tyrannosaurus rex looked different from those of adults. Juvenile bones contained more areas where growth was still taking place. The bone tissue was less dense and showed many signs of active development. Blood vessels inside the growing bones carried nutrients needed for rapid expansion. As the dinosaur became older, the bone tissue became thicker and stronger, allowing it to support much greater weight. The skull also changed greatly during growth. A young Tyrannosaurus rex had a narrower head with a longer appearance. The face became deeper and wider, as it matured. The bones of the skull gradually fused together more firmly, creating a stronger structure capable of handling powerful bites. The spaces between some skull bones became tighter, reducing movement and increasing overall strength. The teeth also changed throughout life. Juveniles possessed sharp teeth that were well suited for catching smaller, faster prey. As the animal aged, the teeth became thicker and stronger. Adult teeth developed the famous heavy shape that allowed them to crush bone while biting into large animals. New teeth continuously replaced older ones throughout life. When a tooth broke or fell out, another tooth slowly moved into its place. This process allowed Tyrannosaurus rex to maintain an effective set of teeth even after repeated use. The jaws became much more powerful during development. Muscles attached to the skull increased greatly in size. The bones supporting these muscles also became stronger. As a result, the bite force increased year after year. A small juvenile could capture only modest prey, while a mature adult possessed one of the strongest bites known among land animals. The neck also experienced important changes. Young individuals had lighter neck muscles because they carried smaller heads. As the skull became larger and heavier, the neck muscles expanded to support its increasing weight. Strong neck muscles also helped the animal tear flesh, shake prey, and lift heavy pieces of meat while feeding. The arms remained small throughout life, but they did not stop growing. Juveniles had proportionally slightly longer arms than adults, although the difference was not extreme. The arms became stronger as muscles developed, and the two clawed fingers remained useful for grasping objects at close range. Even though the arms never reached the size seen in many other meat-eating dinosaurs, they were supported by solid bones and powerful muscles. The legs changed dramatically during growth. Young Tyrannosaurus rex had long, slender legs that helped them move quickly. Fast movement was valuable because smaller predators often depended on speed to catch prey and avoid danger. As body weight increased, the legs became thicker and stronger. The bones widened, joints became larger, and muscles increased in size. Adults could still move efficiently, but their great body mass required much stronger limbs than those of juveniles. The feet also developed steadily. Each toe became stronger as the animal gained weight. Thick pads beneath the feet helped spread body weight across the ground. Large claws provided grip while walking, running, and hunting. As the skeleton matured, the feet became capable of supporting enormous mass without collapsing under pressure. The tail was another important part of development. In young Tyrannosaurus rex, the tail already helped maintain balance while moving. As the animal grew, the tail lengthened and became much heavier because of larger muscles and thicker bones. The tail balanced the heavy head and body, helping the dinosaur remain stable during walking and hunting. The senses also developed throughout growth. The eyes became larger, improving vision. Young individuals probably relied heavily on sharp eyesight to detect prey and avoid danger. As the skull matured, the position of the eyes allowed strong forward vision that may have improved depth perception. Good vision would have helped Tyrannosaurus rex judge distance while hunting. The brain also grew during development. Although the brain remained small compared with total body size, it controlled increasingly complex movements, hunting behaviour, balance, and the senses. Nerves connected every part of the body, allowing muscles to respond quickly to changing situations. The sense of smell likely became stronger as the skull expanded. The parts of the brain associated with smell were well developed in Tyrannosaurus rex. A powerful sense of smell could have helped locate food over long distances, recognize other members of its species, and detect possible danger. Hearing also played an important role. The inner ear developed as the young dinosaur matured. Good hearing allowed it to notice approaching animals, communicate through sounds, and remain alert within its environment. During the juvenile stage, Tyrannosaurus rex probably lived a very different lifestyle from adults. Its lighter body and faster movement allowed it to hunt smaller prey. This reduced direct competition with fully grown adults that focused on much larger animals. Such differences in feeding habits would have allowed different age groups to live within the same environment while using different food sources. As growth continued, the body entered an important stage known as adolescence. During this period, the dinosaur was no longer a small juvenile, but had not yet reached full adult size. Bones lengthened rapidly, muscles expanded quickly, and body weight increased at an impressive rate. Fossil evidence suggests that Tyrannosaurus rex experienced a period of especially fast growth during its teenage years. Scientists estimate that during this rapid growth period, Tyrannosaurus rex could gain hundreds of kilograms in body weight each year. Such fast growth required large amounts of food. The digestive system had to process enough nutrients to support expanding muscles, bones, skin, and internal organs. A healthy supply of prey was essential during these years. Rapid growth affected the entire skeleton. The leg bones became much thicker. The hips widened to support increasing body mass. The backbone strengthened as each vertebra became larger and more heavily built. Ligaments and tendons connecting the bones also became stronger to handle greater physical stress. The chest expanded as the lungs and heart supported the larger body. Efficient breathing supplied oxygen to growing muscles. The heart pumped blood through an increasingly complex network of blood vessels that reached every tissue. This circulation system carried nutrients, oxygen, and waste products throughout the body. The skin also changed during development. As body size increased, new layers of skin formed continuously. The skin protected the body from injury, helped reduce water loss, and formed a barrier against harmful organisms. Small scales covered much of the skin, although some areas may have supported simple feather-like structures during certain stages of life. Color patterns may also have changed with age, although fossil evidence cannot yet provide definite answers. Modern animals often display different colors as they mature, and dinosaurs may have done the same. Patterns could have provided camouflage, helped identify members of the same species, or played a role during courtship. Growth was not always smooth. Illness, injury, shortages of food, drought, floods, volcanic activity, or changing seasons could slow development. Bone growth rings sometimes suggest periods when growth became slower, possibly because environmental conditions reduced the amount of available food. Once conditions improved, growth could become faster again. Injuries also left lasting marks on growing bones. Some Tyrannosaurus rex fossils preserve healed fractures, bite marks, infections, and damaged joints. These healed injuries show that many individuals survived serious accidents. Young animals that recovered from injuries continued growing, although some bones remained permanently changed. Parasites and diseases may also have affected development. Like modern animals, Tyrannosaurus rex probably faced infections caused by bacteria, viruses, fungi, or parasites. Some diseases may have left visible marks on bones, while others affected only soft tissues that rarely fossilize. Nutrition played a major role throughout life. A growing Tyrannosaurus rex required protein for muscles, minerals for bones, fats for stored energy, and many other nutrients for healthy development. Individuals living in areas with abundant prey probably grew more successfully than those facing frequent food shortages. Climate also influenced growth. Tyrannosaurus rex lived during the Late Cretaceous, when much of the world experienced warm temperatures. Seasonal changes still occurred, affecting rainfall, plant growth, and the populations of plant-eating dinosaurs. These environmental changes influenced how much food became available for large predators. As the dinosaur approached adulthood, many body proportions began reaching their final form. The skull became extremely massive. Jaw muscles reached enormous size. Teeth became thick and widely spaced. The legs developed enough strength to support the full adult body. The chest became deeper and the tail carried heavy muscles that balanced the rest of the body. Sexual maturity probably arrived before maximum body size was reached. This means a Tyrannosaurus rex may have become capable of reproducing, while still continuing to grow, for several more years. Many living reptiles and birds show similar patterns of development. Exact ages remain uncertain, because scientists continue studying fossil evidence. Adult females may have faced additional physical demands, because producing eggs required large amounts of energy and minerals. Calcium stored within the body helped form eggshells. During breeding seasons, females may have temporarily directed more nutrients toward reproduction than toward continued body growth. The reproductive organs themselves almost never fossilize because they consist of soft tissues. Scientists instead study bones and compare Tyrannosaurus rex with living birds and reptiles to estimate how reproduction occurred. Occasionally, special bone tissue associated with egg production has been identified in some dinosaurs, providing valuable evidence for reproductive biology. Once full adulthood was reached, growth slowed greatly. Bones no longer lengthened significantly, although they continued repairing themselves throughout life. Muscles remained strong through regular activity, and body weight depended partly on the availability of food. Adults represented the largest and strongest stage of the life cycle. An adult Tyrannosaurus rex possessed powerful jaws, massive leg muscles, strong bones, excellent senses, and a body well suited for hunting large prey. These features had developed gradually through many years of steady growth. Every stage of development contributed to the final adult form. Even after reaching adulthood, the body continued changing slowly through aging. Older individuals may have developed arthritis in their joints after years of supporting great weight. Repeated injuries accumulated over time. Teeth broke and were replaced many times. Bones sometimes healed after fractures, leaving permanent evidence visible in fossils. Some older Tyrannosaurus rex fossils show rough bone surfaces that indicate infections or healed wounds. Others preserve fused bones caused by injury or disease. These features provide important clues about the health of aging individuals and demonstrate that many survived difficult physical conditions. Wear on the teeth increased throughout adult life. Repeated biting against bone caused damage that accumulated over many years. Fortunately, replacement teeth continued growing beneath older teeth, allowing the animal to maintain an effective bite even after heavy use. The skull also accumulated signs of age. Bite marks from fights with other Tyrannosaurus rex individuals have been discovered on several fossil skulls. Some injuries healed completely, showing that these animals survived encounters with members of their own species. The skeleton continued repairing microscopic damage caused by daily movement. Bone is living tissue that constantly rebuilds itself. Cells removed old bone and replaced it with new material throughout the dinosaur's lifetime. This process helped maintain strength despite constant physical stress. Scientists estimate the ages of Tyrannosaurus rex individuals mainly through bone histology. Thin sections cut from fossil bones reveal growth rings that formed over time. Younger individuals display widely spaced rings showing rapid growth. Older adults show closely packed rings that indicate growth had slowed. Some Tyrannosaurus rex individuals probably lived into their late 20s or around 30 years of age. Very few appear to have survived much longer. This lifespan reflects both natural aging and the many dangers faced throughout life, including disease, injury, starvation, environmental changes, and competition. Not every Tyrannosaurus rex grew at exactly the same rate. Individual differences existed just as they do among living animals. Genetics influence body size, growth speed, and overall health. Environmental conditions also affected development. Access to food, exposure to disease, injuries, and local climate all contributed to individual variation. Scientists have discovered Tyrannosaurus rex fossils representing several stages of growth. Although complete skeletons from every age remain rare, each new discovery fills another gap in the life history of this species. Small juveniles are especially uncommon because their lighter bones were more fragile and less likely to survive the fossilization process. Modern technology has greatly improved the study of growth and development. Computed tomography scanning allows scientists to examine the inside of fossil bones without destroying valuable specimens. Microscopes reveal tiny structures within bone tissue that record patterns of growth. Digital models help researchers measure changes in skull shape, body proportions, and muscle attachments during different stages of life. Scientists also compare Tyrannosaurus rex with living birds and crocodilians, because these animals are its closest living relatives. Birds provide valuable information about growth, reproduction, and bone development, while crocodilians help explain aspects of body structure and behaviour. These living animals cannot provide complete answers, but they offer useful clues when combined with fossil evidence. Bone chemistry has become another important area of research. Minerals preserved inside fossils sometimes reveal details about growth, nutrition, and health. Scientists carefully analyze these chemical signals to better understand the biology of extinct animals. The study of growth has also changed earlier ideas about Tyrannosaurus rex. Many fossils once believed to belong to different species are now recognized as younger or older individuals of the same species because researchers better understand how body shape changes during development. As more fossils are discovered, these interpretations continue becoming more accurate. The entire life of Tyrannosaurus rex involved constant change from the earliest stage inside the egg through hatching, juvenile growth, adolescence, adulthood, and old age. Every organ, bone, muscle, tooth, and body system developed gradually over many years. Fossils preserve many of these changes, allowing scientists to reconstruct the life history of one of the best-known dinosaurs ever discovered. Each new specimen provides additional information about how young individuals grew, how rapidly they reached adulthood, how their bodies responded to injury and disease, and how aging affected them during the final years of their lives. The diet and hunting behaviour of Tyrannosaurus rex have fascinated scientists and dinosaur enthusiasts for many years. This giant meat-eating dinosaur lived during the final part of the Late Cretaceous Period, several million years before the extinction of the non-avian dinosaurs. Fossils found across western North America have provided a large amount of information about how this powerful animal lived, moved, searched for food, and survived in its environment. Even though no human ever saw Tyrannosaurus rex alive, scientists have carefully studied its bones, teeth, fossilized footprints, bite marks, and the remains of animals that lived alongside it. These discoveries allow researchers to build a detailed picture of what this dinosaur probably ate and how it found its meals. Tyrannosaurus rex was a carnivore. This means that it lived by eating the flesh of other animals. Its body was built in ways that supported this kind of diet. It had an enormous skull, very strong jaw muscles, thick neck muscles, and large teeth that could crush bone. Every part of its head worked together to help it catch prey, tear flesh, and break apart even the hardest parts of an animal's skeleton. Unlike many smaller meat-eating dinosaurs that had narrow teeth shaped for slicing, Tyrannosaurus rex had thick teeth that were almost round in cross-section. This shape made them much stronger and less likely to break while biting into bone. The teeth of Tyrannosaurus rex were among the largest of any known land predator. Some teeth were about the length of a human forearm when including the root. The visible part above the gum was shorter but still very large. These teeth were not all the same shape. The front teeth were slightly different from those on the sides of the mouth. The front teeth helped grip struggling prey, while the side teeth were better suited for cutting and crushing. Tiny saw-like edges called serrations lined the edges of the teeth. These sharp edges helped tear through skin, muscle, and other soft tissues. Like many reptiles, Tyrannosaurus rex replaced its teeth throughout its life. A damaged or worn tooth would eventually fall out and be replaced by a new one growing underneath. This continuous replacement meant that the dinosaur almost always had working teeth, even after losing some during feeding or hunting. Fossils have been found with replacement teeth growing inside the jaw, showing that this process happened naturally throughout its lifetime. The jaws of Tyrannosaurus rex were among the strongest ever known in a land animal. Scientists have used computer models, studies of living animals, and careful examination of fossil bones to estimate the strength of its bite. These studies suggest that its bite force reached several tons of pressure. Such an enormous bite allowed it to crush bones that many other predators could not break. Instead of carefully avoiding bones while feeding, Tyrannosaurus rex often bit directly through them. Broken bones with deep tooth marks have been found in many fossil sites, showing that this dinosaur regularly crushed skeletons while eating. Its powerful bite provided many advantages. Bone contains valuable nutrients, especially fat stored inside the marrow. By breaking open large bones, Tyrannosaurus rex gained access to food that other animals could not easily reach. This meant that even after much of the meat had been eaten, there was still useful nutrition remaining inside the skeleton. Fossilized droppings believed to have come from large meat-eating dinosaurs contain crushed bone fragments, showing that bone was swallowed and passed through the digestive system. The neck of Tyrannosaurus rex was also very important during feeding. Strong muscles attached to the skull and neck gave the dinosaur the ability to pull large pieces of meat from carcasses. After biting into flesh, it could pull backward with great force to tear away chunks of food. Thick neck vertebrae supported these heavy muscles and helped carry the enormous head while also providing strength during feeding. Scientists believe that Tyrannosaurus rex had excellent senses that helped it locate food. Its large eyes faced forward, allowing both eyes to focus on the same object. This created binocular vision, which improved depth perception. Good depth perception would have helped judge distances accurately while approaching prey or moving through forests and river valleys. The large eye sockets suggest that its eyesight was probably very sharp. The brain of Tyrannosaurus rex also gives clues about its senses. Studies of fossil skulls show that the parts of the brain connected with smell were especially large. This indicates that it had a highly developed sense of smell. It may have been able to detect the scent of dead animals from long distances. A strong sense of smell could also have helped locate living prey hidden among plants or follow scent trails left by wounded animals. Its hearing may also have been well developed. The structure of the inner ear suggests that Tyrannosaurus rex could hear low-frequency sounds effectively. Low sounds often travel farther than high sounds, especially through forests and across open land. Good hearing would have helped detect movement, recognize calls from other dinosaurs, or become aware of animals moving nearby. The environment where Tyrannosaurus rex lived supported many kinds of plant-eating dinosaurs. Large duck-billed dinosaurs, horned dinosaurs, armored dinosaurs, and smaller herbivores shared the same landscape. Rivers flowed across broad plains filled with forests, ferns, flowering plants, and conifers. These environments provided food for large plant eaters, which in turn became potential food sources for large predators. Among the most common large plant-eating dinosaurs living alongside Tyrannosaurus rex were duck-billed dinosaurs, such as these animals often lived in groups and reached impressive sizes. Even though the adults were large, young individuals may have been easier targets. Fossils show that Tyrannosaurus rex bit the bones of these dinosaurs, leaving clear tooth marks that match its distinctive teeth. Another important possible prey animal was this famous horned dinosaur possessed a large bony frill and 3 sharp horns that provided protection. Hunting such an animal would have been dangerous because its horns could seriously injure a predator. Fossils of Triceratops have been found with healed bite marks believed to have been made by Tyrannosaurus rex. Since the wounds healed, the animals survived the attacks, providing direct evidence that at least some encounters occurred while both animals were alive. Scientists continue to discuss whether Tyrannosaurus rex mainly hunted living animals, mainly scavenged dead animals, or did both. Many researchers now believe that it had probably used both methods depending on the situation. In nature, many large meat-eating animals take advantage of every available food source. If a fresh carcass could be found without much effort, eating it would save energy and reduce the risk of injury. If suitable prey was available, hunting would provide another important source of food. This flexible feeding strategy would have increased the chances of survival. The idea that Tyrannosaurus rex was only a scavenger has become much less widely accepted because several pieces of evidence suggest active hunting. Healed bite marks on prey animals show attacks that occurred while those animals were alive. Bite forces capable of quickly disabling prey also support active hunting. Its forward-facing eyes, excellent vision, strong legs, and well-developed senses all fit the lifestyle of an active predator. At the same time, there is also strong evidence that Tyrannosaurus rex fed on dead animals whenever possible. Its powerful sense of smell would have made finding carcasses easier. Bone-crushing teeth allowed it to consume nearly every part of an animal, including parts ignored by smaller predators. Eating dead animals would have reduced the need to chase dangerous prey every day. A large predator required an enormous amount of food. Although estimates differ, an adult Tyrannosaurus rex probably consumed large meals whenever possible. It may not have needed to eat every day if it successfully fed on a very large carcass. Modern reptiles often eat large meals, followed by periods without feeding, while birds usually eat more frequently. Since Tyrannosaurus rex belonged to the dinosaur group that eventually gave rise to birds but also shared many features with reptiles, scientists continue to study how often it likely ate. When hunting, Tyrannosaurus rex probably relied on surprise, strength, and short bursts of movement rather than long-distance pursuit. Its body was very large and heavily built. Although it had long legs for its size, many scientists think it was not capable of extremely high speeds because the stress on its bones would have been too great. Instead, it may have approached prey carefully before making a rapid attack over a shorter distance. Its tail played an important role during movement. The long, heavy tail balanced the large head and body, helping maintain stability while walking or running. Strong muscles attached to the tail also powered the legs. This arrangement allowed the dinosaur to move efficiently despite weighing several tons. The legs of Tyrannosaurus rex were among the strongest of any large meat-eating dinosaur. Thick thigh bones and powerful muscles supported its great weight while still allowing it to travel across floodplains, forests, and muddy ground. Fossil footprints made by large meat-eating dinosaurs suggest steady movement over long distances while searching for food. The small arms of Tyrannosaurus rex have often attracted attention because they appear tiny compared to the rest of the body. Although short, the arms were heavily built with large muscles. Each hand carried 2 strong claws. Scientists are still studying exactly how these arms were used. During feeding, they may have helped hold struggling prey at close range, assisted while rising from the ground, or played a role during mating or other behaviours. The arms were probably not the main tools for catching prey, because the jaws performed most of the work. Once Tyrannosaurus rex reached a prey animal, its jaws became the primary weapon. A powerful bite delivered to the neck, body, or hips could cause severe injuries. Crushing bones would weaken the prey quickly and make escape difficult. Repeated bites would eventually bring the animal down. Because of its enormous strength, even a single successful bite may have caused devastating damage. Scientists have studied bite marks preserved on fossil bones to understand feeding behaviour. These marks often appear as deep grooves, punctures, or broken sections of bone. In some fossils, the bite marks match the spacing and size of Tyrannosaurus rex teeth, almost exactly. Some bones even contain broken Tyrannosaurus teeth that snapped off during feeding. Since replacement teeth grew continuously, losing a tooth while feeding would not have created a serious long-term problem. Evidence suggests that Tyrannosaurus rex did not always begin eating the same part of a carcass. Bite marks appear on many different bones throughout the skeleton. This indicates that it probably fed wherever it could easily access meat. Strong jaws allowed it to remove large muscle groups from the legs, hips, shoulders, neck, and tail. After most flesh had been consumed, it continued breaking bones to reach marrow and other nutritious tissues. Some fossil sites contain several Tyrannosaurus rex individuals together. Scientists continue discussing what this means. It is possible that several individuals gathered around a large carcass. Modern large predators sometimes tolerate one another briefly while feeding, although fights may occur over access to food. Tooth marks on Tyrannosaurus rex bones suggest that members of the same species sometimes bit one another. These injuries may have resulted from competition over food, territorial disputes, or mating behaviour. Cannibalism may also have occurred. Several Tyrannosaurus rex bones contain tooth marks matching the size and shape of Tyrannosaurus teeth. Since these bones belong to the same species, at least some individuals appear to have fed on other Tyrannosaurus rex carcasses. This does not necessarily mean they hunted one another regularly. Feeding on already dead members of their own species would still provide valuable nutrition. Young Tyrannosaurus rex probably hunted differently from adults. Juveniles had longer legs relative to their body size, slimmer bodies, and narrower skulls. Their teeth were also more blade-like than those of fully grown adults. These features suggest they may have focused on smaller, faster prey that required speed rather than overwhelming strength. As they matured, their bodies became heavier, their skulls broader, and their bite force much greater. This change allowed adults to specialize in attacking much larger animals. The changing diet throughout life may have reduced competition between young and adult Tyrannosaurus rex. Smaller individuals could hunt animals that adults rarely targeted, while adults focused on larger prey. This meant different age groups may have used different food resources even while living in the same environment. Growth studies based on fossil bones show that Tyrannosaurus rex experienced periods of rapid growth during adolescence. During these years, it would have needed increasing amounts of food to support its expanding muscles, bones, and organs. Large meals rich in protein and fat helped fuel this rapid development. Scientists examine microscopic growth rings inside fossil bones to estimate age. These rings reveal that many Tyrannosaurus rex individuals lived for several decades. Throughout those years, successful feeding remained essential for survival. Injuries, illness, drought, flooding, or changing prey populations could all affect access to food. Seasonal changes may also have influenced hunting behaviour. River levels changed throughout the year and plant growth affected where herds of herbivorous dinosaurs gathered. Predators likely followed these shifting food sources. During dry periods, animals often concentrated around remaining water supplies, making prey easier to locate. Wet seasons may have spread animals over wider areas. Floodplains, where Tyrannosaurus rex lived, supported many waterways filled with fish, turtles, crocodile relatives, amphibians, and other animals. Although large dinosaurs probably formed the main part of its diet, it's possible that Tyrannosaurus rex occasionally ate smaller animals when opportunities arose. A large predator usually benefits from taking advantage of any suitable food source rather than ignoring available meals. Competition with other large predators was probably limited because Tyrannosaurus rex occupied the highest predator role in its environment during the latest part of the Cretaceous in western North America. Earlier periods contained several different giant predators living together, but by the time Tyrannosaurus rex appeared, few equally large meat-eating dinosaurs remained in the same regions. This may have allowed it to dominate the available large prey. Its digestive system had to process large quantities of meat, fat, skin, connective tissue, and bone. Although soft tissues rarely fossilize, scientists infer that its digestive organs efficiently extracted nutrients from these materials. Strong stomach acids may have helped dissolve bone fragments swallowed during feeding. After eating a large meal, Tyrannosaurus rex may have rested while digestion took place. Digestion requires energy, especially after consuming large amounts of food. During this time, it would have remained alert for competitors or scavengers attracted by the smell of the carcass. The smell of a freshly killed animal likely attracted many smaller meat-eaters. Small theropods, early mammals, crocodile relatives, and other scavengers may have waited nearby for opportunities to feed after Tyrannosaurus rex finished eating. Even after the largest predator departed, valuable meat and bone remained for many other animals. Scientists have discovered healed injuries on Tyrannosaurus rex skeletons that show these animals sometimes survived serious wounds. Broken ribs, damaged jaws, infected bones, and healed bite marks reveal difficult lives. Hunting dangerous prey carried significant risks. A kick, horn strike, fall, or bite from a struggling victim could cause severe injuries. Even if a hunt succeeded, the predator might suffer lasting damage. One famous Tyrannosaurus rex specimen shows signs of infection in its jawbones. Other specimens display broken bones that healed over time. These discoveries indicate that injured individuals could survive for months or even years after being wounded. During recovery, scavenging may have become especially important because chasing prey would have been more difficult. Some researchers have suggested that Tyrannosaurus rex may have occasionally hunted in groups, while others believe it usually hunted alone. Evidence remains uncertain. Several fossil discoveries containing more than one Tyrannosaurus individual have encouraged discussion, but they do not provide definite proof of organized group hunting. The animals could simply have gathered around food or died during the same event. At present, scientists continue examining new fossils to better understand this question. If group hunting occurred at least occasionally, it may have allowed attacks on especially large prey. Several individuals working together could surround an animal and reduce its chance of escape. However, living and feeding in groups also creates competition over food. Without direct evidence, researchers remain careful about drawing firm conclusions. The brain of Tyrannosaurus rex was relatively large for a dinosaur of its size. Certain areas associated with coordination, vision, smell, and balance were well developed. Good coordination would have been important while aiming powerful bites at moving prey. Maintaining balance while carrying such a massive head also required precise control of body movements. The inner ear helped maintain balance during movement. Fossil evidence suggests that Tyrannosaurus rex could keep its head steady while walking or running. Stable vision improves the ability to judge moving targets and navigate uneven ground. Its skin likely included scales over most of the body, although some close relatives possessed feathers on parts of their bodies. Adult Tyrannosaurus rex probably relied primarily on its large size for protection rather than feathers. The skin around the face may have contained sensitive nerves that detected pressure and touch. Such sensitivity could help while biting, handling food, or interacting with other Tyrannosaurus individuals. Facial nerves may also have helped judge exactly how hard to bite. Delivering enough force to hold prey without damaging teeth unnecessarily would have required careful control. Even though replacement teeth were available, avoiding unnecessary tooth breakage would still have been beneficial. Scientists continue using modern technology to study Tyrannosaurus rex feeding behaviour. Three-dimensional computer models recreate skull movement and estimate muscle strength. Medical scanners reveal hidden structures inside fossil bones. Digital reconstructions allow researchers to examine bite mechanics without damaging valuable fossils. These methods continue improving our understanding of how the skull functioned during hunting and feeding. Chemical studies of fossil bones also provide information about diet. Different foods leave slightly different chemical signals inside growing bones and teeth. By examining these signals, researchers can learn about the position of Tyrannosaurus rex within ancient food chains. Results consistently support its role as a top meat-eating predator. Fossilized stomach contents are extremely rare, but occasional discoveries from other dinosaurs help scientists understand feeding relationships within ancient ecosystems. Tooth marks, broken bones, fossilized droppings, and healed injuries remain the strongest evidence for studying Tyrannosaurus rex feeding habits. The large size of Tyrannosaurus rex affected every aspect of its hunting strategy. Growing to such enormous proportions required huge amounts of energy, but that same size provided advantages during feeding. Large prey offered more food than smaller animals, making each successful hunt especially valuable. Strong muscles, thick bones, and massive jaws allowed the dinosaur to overpower animals that few other predators could challenge. Its daily activities probably included long periods spent moving through its territory in search of food. It may have followed rivers, crossed open plains, entered forests, and visited places where herbivorous dinosaurs gathered. A well-developed sense of smell increased the chances of finding fresh carcasses or detecting living animals hidden nearby. Wind direction may have influenced hunting. Moving against the wind could reduce the chance that prey would detect its scent, while travelling with the wind would carry the smell of dead animals toward the predator. Many living predators pay close attention to wind conditions, and Tyrannosaurus rex may have done the same. Young animals, old individuals, injured dinosaurs, or isolated members of herds were probably easier targets than healthy adults surrounded by companions. Choosing vulnerable prey would reduce the risk of injury while increasing the chance of a successful hunt. Natural selection favors behaviors that improve survival while limiting unnecessary danger. Large herbivorous dinosaurs developed many defenses against predators. Some carried horns, others possessed armored skin, heavy tails, or sheer body size. Many likely remained alert for danger while feeding. Some species may have stayed in groups, allowing several individuals to watch for approaching predators. Tyrannosaurus rex had to overcome these defenses through careful timing, powerful attacks, and persistence. Weather also affected hunting conditions. Rain created muddy ground that slowed movement for both predators and prey. Flooding changed river channels and forced animals into new areas. Dry conditions concentrated animals around remaining water sources. These natural changes shaped the movements of both hunters and herbivores throughout the year. As one of the final giant meat-eating dinosaurs before the mass extinction at the end of the Cretaceous period, Tyrannosaurus rex occupied an important place in its ecosystem. By hunting living animals and feeding on carcasses, it helped control prey populations while also removing dead animals from the landscape. Every successful meal supported its continued growth, reproduction, and survival in an environment filled with changing conditions and constant challenges. Fossils discovered over many decades continue to reveal new details about its feeding habits, hunting methods, physical abilities, and interactions with the animals that shared its ancient world, allowing scientists to refine their understanding as new evidence emerges from rocks that have preserved these remains since the closing chapter of the Age of Dinosaurs. The senses of Tyrannosaurus rex played an important part in its daily life. Scientists have studied the skull, brain case, eye sockets, nose, ears, and other parts of its head to understand how this dinosaur may have experienced the world. Although soft tissues such as the eyes, ears, and nose have not been preserved, the bones that supported these organs provide many useful clues. These clues allow scientists to build a picture of how Tyrannosaurus rex may have seen, smelled, heard, and felt its surroundings. One of the strongest senses of Tyrannosaurus rex was probably its sense of smell. Inside its skull were large spaces that held the smell-processing parts of the brain. These areas were much larger than those of many other dinosaurs. This suggests that the animal relied heavily on smells during everyday life. The large openings in the skull for the nose also suggest that it had a well-developed system for detecting odors carried through the air. A powerful sense of smell would have helped Tyrannosaurus rex in many different ways. It could detect the scent of dead animals from a long distance. This would allow it to find food even when it could not see it. Wind could carry the smell of a carcass across forests and open plains. By following stronger and stronger scents, Tyrannosaurus rex may have reached animals that had died naturally or had been killed by other predators. The sense of smell would also have helped it find living prey. Large plant-eating dinosaurs left behind many scents as they moved. They released body odors, left waste on the ground, and disturbed plants and soil. Tyrannosaurus rex may have followed these signs to discover where groups of animals had traveled. This would increase its chances of finding food. Smell may also have helped Tyrannosaurus rex recognize members of its own species. Living animals often use scent to identify other individuals. Different scents may reveal age, health, or breeding condition. Although scientists cannot directly observe this behaviour in extinct dinosaurs, many believe that smell probably played an important role in communication between Tyrannosaurus rex individuals. Young Tyrannosaurus rex may have depended on smell from the time they hatched. Small hatchlings entering the world needed to recognize food and danger quickly. A strong sense of smell would help them detect animals nearby, locate possible meals, and avoid places where larger predators were present. Vision was another very important sense. The eyes of Tyrannosaurus rex faced more toward the front of the skull than those of many other meat-eating dinosaurs. This arrangement allowed the fields of vision from both eyes to overlap. When both eyes focus on the same object, the brain can judge distance more accurately. This ability is called depth perception. Good depth perception would help Tyrannosaurus rex judge how far away another animal was before making a sudden movement. The eye sockets were large enough to hold large eyes. Bigger eyes usually collect more light, making it easier to see during dim conditions such as early morning, evening, or cloudy weather. While it is not certain exactly how well Tyrannosaurus rex could see in darkness, its large eyes suggest that it could probably remain active when light levels were lower than during the brightest part of the day. Scientists have also suggested that Tyrannosaurus rex may have had excellent visual sharpness. A large eye with many light-sensitive cells could allow detailed vision. Sharp eyesight would help the animal notice movement over long distances. It could detect herds moving through forests, animals crossing riverbanks, or possible dangers approaching from far away. Movement is one of the easiest things for many predators to notice. Even a slight movement among plants can attract attention. Tyrannosaurus rex may have been especially good at noticing motion. An animal trying to hide by remaining still might have been harder to detect than one that suddenly began to run. Its eyesight would also help it move safely through its environment. Floodplains contained fallen trees, rocks, muddy ground, streams, and other obstacles. Careful vision would reduce the chance of injury while walking or chasing prey. The brain combined information from both eyes to create a clear picture of the environment. Every moment, the animal had to decide where to place its feet, where other animals were moving, and whether something nearby represented food or danger. Fast processing of visual information would improve survival. Hearing also played an important role in daily life. The bones of the inner ear suggest that Tyrannosaurus rex was able to detect low-frequency sounds especially well. Low sounds travel farther than high sounds under many conditions. This ability would allow the dinosaur to hear distant movements, calls from other Tyrannosaurus rex individuals, or the footsteps of large animals walking across the landscape. Large plant-eating dinosaurs produced heavy footsteps that shook the ground. These sounds may have traveled long distances. Tyrannosaurus rex could possibly detect these sounds before actually seeing the animals themselves. Weather also created many sounds. Wind moved through trees. Rain struck leaves and soil. Rivers flowed across the land. Thunder echoed across the sky during storms. Tyrannosaurus rex had to separate these natural sounds from noises made by living animals. Communication may have included deep calls that traveled over long distances. Although no one knows exactly what sounds Tyrannosaurus rex produced, its hearing suggests that low sounds may have been useful. These calls could help adults locate each other during breeding seasons or warn rivals to stay away from occupied territory. The inner ear also helped control balance. Every step required careful coordination between the brain, eyes, muscles, and inner ear. A large animal weighing several tons needed excellent balance to walk safely across uneven ground. The inner ear constantly informed the brain about the position of the head and body. Touch was another important sense. The skin contained nerves that detected pressure, temperature, and pain. Although fossil skin rarely preserves these tiny structures, living reptiles and birds show that skin is an active sensory organ. Tyrannosaurus rex probably felt changes in temperature as it moved between sunlight and shade. It likely sensed rough surfaces, soft mud, water, and plants brushing against its body. Scientists have found evidence that the snout of Tyrannosaurus rex contained many openings for nerves and blood vessels. These openings suggest that the face may have been sensitive to touch. Sensitive skin around the jaws could help the dinosaur judge the position of objects while feeding. It may also have allowed adults to gently interact with young animals or examine unfamiliar objects. Pain was an important warning signal. Fossils show that many Tyrannosaurus rex individuals survived broken bones, infections, and bite marks. Feeling pain would encourage the animal to protect injured parts of its body while healing. The brain of Tyrannosaurus rex was not enormous compared with the size of its body, but studies suggest that it was well suited to the needs of a large predator. Different parts of the brain specialized in different jobs. Some handled vision, others smell, movement, hearing, memory, and balance. Intelligence does not depend only on brain size. The arrangement of brain regions and how they work together are also important. Tyrannosaurus rex probably possessed enough intelligence to solve everyday problems that affected survival. It likely remembered places where food was often available. Rivers attracted many animals seeking water. Forest edges provided cover. Floodplains supported large herds of plant eaters. Remembering these locations would improve hunting success. Memory would also help Tyrannosaurus rex recognize safe travel routes. Some areas contained deep mud that could trap large animals. Other places offered easier walking. Learning these routes through experience would reduce unnecessary risks. Young Tyrannosaurus rex almost certainly learned as they grew older. Juveniles had different body shapes and probably hunted smaller animals. As they increased in size, they gradually changed their hunting methods. Experience would teach them which prey was easier to catch and which animals were dangerous to attack. Learning from failed attempts was likely very important. Every unsuccessful hunt provided information. A prey animal might escape in a certain direction, react in a predictable way, or defend itself strongly. The predator could remember these experiences and change its behavior during future hunts. The ability to pay attention to changing conditions also reflects intelligence. Seasons affected water levels, plant growth, and animal movements. Tyrannosaurus rex had to notice these changes and adjust its daily activities. Every new day presented different conditions that required Tyrannosaurus rex to remain alert. Some mornings may have begun with cool air and heavy mist covering the ground. At other times, the land may have been dry and warm from the first light of day. Rainstorms could change the shape of rivers, soften the ground, and create new pools of water. Strong winds could spread scents in different directions or cover weaker smells with stronger ones. Tyrannosaurus rex had to react to these changing conditions by using its senses together instead of depending on only one source of information. The brain constantly received signals from the eyes, nose, ears, skin, muscles, and inner ear. These signals arrived every moment while the animal was awake. The brain had to organize this information quickly. It needed to determine whether a sound came from prey, another predator, moving water, or the wind. It had to decide whether a smell meant fresh meat, a living animal, or something that was no longer useful as food. It also had to recognize changes in the ground beneath its feet and judge whether it was safe to continue walking. Scientists believe that Tyrannosaurus rex probably spent a large part of its day searching rather than chasing. Food was not available everywhere. Even in areas where many animals lived, prey could move away before the predator arrived. A successful hunter had to cover long distances and remain patient. This required careful observation instead of constant running. As Tyrannosaurus rex walked across its environment, it probably turned its head often to examine different directions. The movement of the head allowed the eyes to gather information from a wider area. It also helped the nose sample different air currents, carrying scents from many directions. Small changes in wind direction could suddenly reveal the presence of animals that had previously remained hidden. Fresh footprints left by other dinosaurs may also have provided useful information. A recently made track suggested that an animal had passed through the area not long before. Broken branches, crushed plants, disturbed soil, and fresh waste could all serve as signs that living animals were nearby. Tyrannosaurus rex probably paid close attention to these details while moving across the landscape. Its daily life was not limited to hunting. Drinking water was necessary for survival. Rivers, streams, ponds, and lakes provided places where many animals gathered. These locations were often busy because plant eaters came to drink regularly. Smaller meat-eating dinosaurs also visited these places. Tyrannosaurus rex may have approached water carefully, using its senses to check whether other large animals were already nearby. Rest was another important part of daily life. Large animals require energy to move their heavy bodies. Constant activity would waste valuable strength. Tyrannosaurus rex probably spent periods standing quietly or lying down in safe areas while recovering energy after long walks or after eating a large meal. Reproduction, nesting, and raising young were some of the most important parts of the life cycle of tyrannosaurs. Every generation depended on successful breeding, healthy eggs, safe nests, and the survival of young animals until they became adults. Although no one has ever seen a living tyrannosaur caring for its family, scientists have learned a great deal by studying fossil bones, fossil eggs, fossil nests, footprints, and the behaviour of living birds and crocodilians, which are the closest living relatives of dinosaurs. Each new discovery helps build a clearer picture of how these giant meat-eating dinosaurs may have brought new life into the world, and how their young slowly grew into powerful hunters. Like other dinosaurs, tyrannosaurs reproduced by laying eggs. They did not give birth to live young. The female produced eggs inside her body after mating with a male. During the breeding season, changes in the body prepared both males and females for reproduction. Hormones controlled these changes just as they do in many animals living today. These changes likely affected behaviour, appetite, and activity levels. Adult tyrannosaurs probably became more interested in finding mates than in their normal daily routines. Finding a suitable mate was an important step. Scientists do not know exactly how tyrannosaurs attracted partners because soft body features, skin colours, and sounds are rarely preserved in fossils. It is possible that adults used deep calls that carried across long distances. Large bodies and powerful lungs could have produced low sounds that travelled through forests and open plains. These calls may have helped individuals locate each other over wide areas. Body movements may also have played a role. Adults could have raised their heads, moved their tails, or changed their posture during courtship. Such actions are common among many living animals during the breeding season. Some dinosaurs had bright feathers or colourful skin, although it remains uncertain where the large tyrannosaurs had noticeable colours. Fossil skin impressions show that much of the body was covered with scales. Some scientists think that young tyrannosaurs may have had more feather-like coverings than adults, but there is no complete agreement about the amount of feathers on fully grown Tyrannosaurus rex. Smell may also have been important during courtship. Tyrannosaurs had an excellent sense of smell because the parts of their brains connected with detecting odours were highly developed. Chemical signals released by the body may have helped males and females recognise when another individual was ready to breed. Strong smelling ability could also have helped them identify healthy partners. Large body size meant that breeding probably required enough open space for both animals. Mating among giant dinosaurs would have involved careful positioning because of their enormous weight and long tails. Although the exact details remain uncertain, scientists believe the process was similar in general to that of living reptiles and birds, involving direct transfer of reproductive cells from the male to the female. After successful mating, the female began producing eggs. Egg formation required large amounts of calcium and other nutrients. Calcium was especially important because it formed the hard shell around each egg. The female needed a healthy diet during this period to supply enough minerals for developing eggs while still maintaining her own body. Meat from hunted animals provided protein, fats, and many minerals needed for egg production. Studies of dinosaur bones have revealed a special kind of temporary tissue known as medullary bone in some female dinosaurs. This tissue forms inside the bones before eggs are laid. It serves as a storage place for calcium that is later used to build eggshells. Similar tissue develops in many living female birds before laying eggs. The discovery of medullary bone in some dinosaurs gives scientists strong evidence that tyrannosaurs and other dinosaurs shared important reproductive features with birds. The female probably searched carefully for a nesting site before laying her eggs. Choosing the right location could make the difference between success and failure. A poor nesting area could expose eggs to floods, predators, harsh weather, or unstable ground. A safer location increased the chances that embryos would survive until hatching. The nesting site may have been on slightly raised ground where rainwater could drain away. Areas with soft soil, sand, or loose plant material would have been easier to shape into a nest. Dense vegetation may have offered some protection by hiding the nest from predators while still allowing the adults to move freely nearby. Scientists have found dinosaur nests belonging to many species around the world. These discoveries show different nesting styles. Some dinosaurs dug shallow pits in the ground. Others built circular nests using soil and plants. Although no complete nest has been proven beyond doubt to belong to Tyrannosaurus rex, researchers believe tyrannosaurs probably prepared simple nests on the ground rather than building complicated structures. The female may have used her powerful hind feet to scrape away loose soil and create a shallow depression. She could also have pushed leaves, small branches, and other plant material into the nest. Such material may have helped keep the eggs warm and protected. Rotting plants produce heat as they break down, which could have added warmth around the eggs. Egg-laying probably took several hours. The eggs were laid one after another instead of all at once. Each egg had a hard shell that protected the growing embryo while allowing oxygen to enter through tiny openings. These microscopic openings also allowed carbon dioxide and water vapor to leave the egg. The eggs themselves were probably larger than those of many smaller dinosaurs, but still much smaller than the adult animal. Even the largest egg represented only a tiny beginning for an animal that would eventually weigh several tons. The shells needed to be strong enough to resist damage while still allowing the young dinosaur to break free when development was complete. The number of eggs laid during one nesting season remains uncertain. Some meat-eating dinosaurs appear to have laid several eggs at a time. Scientists think tyrannosaurs may also have produced a group of eggs instead of only one or two. Producing several offspring increased the chance that at least some young would survive to adulthood, since many dangers threatened eggs and hatchlings. The eggs were probably arranged in an organized pattern inside the nest. Fossil nests from related dinosaurs often show eggs placed in circles or partial circles rather than scattered randomly. Careful placement may have helped distribute warmth evenly and prevented eggs from crushing one another. Once the eggs had been laid, they entered a long period of development. Inside each shell, a tiny embryo slowly grew. Cells divided again and again, forming tissues, organs, muscles, bones, nerves, skin, and internal organs. Over time, the embryo developed claws, jaws, eyes, legs, and a tail. Blood vessels spread through membranes inside the egg, carrying nutrients from the yolk to every growing part of the body. The yolk provided nearly all the food needed before hatching. It contained proteins, fats, vitamins, minerals, and stored energy. The embryo gradually absorbed these nutrients as it grew larger. By the time hatching approached, much of the yolk had been used. Temperature probably played an important role in successful development. Eggs that became too cold or too hot might not survive. The nesting site therefore needed conditions that remained fairly stable throughout incubation. Plant material, sunlight, soil, and perhaps body heat from attending adults may all have contributed to maintaining suitable temperatures. Scientists continue to debate whether tyrannosaur parents sat directly on their nests like many birds. Fully grown adults were extremely heavy, making it possible that their weight could damage fragile eggs. Instead of sitting directly on them, adults may have stood beside the nest or rested nearby while guarding it. They could have shaded the eggs during hot weather or protected them from predators without placing their full weight on the shells. Predators posed one of the greatest dangers during incubation. Small meat-eating dinosaurs, mammals, lizards, snakes, and other animals may have searched for unattended eggs. Eggs contained rich nutrients and were valuable food sources. Constant protection greatly increased the chances that embryos would survive. Adult tyrannosaurs possessed powerful jaws capable of driving away many threats. Their large size alone may have discouraged smaller predators from approaching the nest. Even if adults spent part of the day searching for food, they may have returned frequently to check the safety of the eggs. Some scientists believe both parents may have participated in protecting nests, while others think the female may have carried most of the responsibility. Fossils have not yet provided enough direct evidence to answer this question with certainty. Different dinosaur species may also have shown different levels of parental care. Weather created additional challenges. Heavy rain could flood nests placed in low areas. Strong winds might blow away loose nesting material. Extremely hot days could overheat exposed eggs, while cold nights might slow embryo development. Choosing the right nesting location reduced these risks. The incubation period probably lasted many weeks. During this time, the embryo continued growing steadily inside the shell. Bones hardened as minerals were deposited. Muscles became stronger. Internal organs reached full development. Tiny teeth formed inside the jaws before hatching. As the young dinosaur neared the end of development, it prepared to leave the egg. Near the tip of its snout was a temporary structure called an egg tooth. This sharp point was not a true permanent tooth, but a special feature used only for hatching. It helped crack the shell from the inside. hatching was a slow process rather than a sudden event. The baby repeatedly pushed against the shell until small cracks appeared. Gradually, larger pieces broke away. Eventually, the hatchling emerged into the outside world. Soon afterward, the egg tooth was no longer needed and disappeared. Freshly hatched tyrannosaurs were much smaller than adults. They probably weighed only a few kilograms. Their bodies were light, their legs relatively long, and their heads proportionally smaller than those of fully grown adults. These body proportions made young animals quicker and more agile than the massive adults they would eventually become. Their skin may have been covered partly by feather-like structures that helped conserve body heat. Some evidence from close relatives suggests that young tyrannosaurs may have carried more body covering than adults, although the exact amount remains uncertain because direct fossil evidence is limited. The hatchlings already possessed sharp teeth. Even at a young age they were meat-eaters. However, they were too small to hunt large animals. Instead, they probably fed on insects, small reptiles, mammals, frogs, fish, and other tiny prey that matched their size and abilities. Parental care after hatching remains one of the biggest questions in dinosaur research. Some scientists think tyrannosaur parents guarded and protected their young for an extended period. Others suggest that care may have ended shortly after hatching. Fossils from many dinosaur groups indicate that at least some species invested considerable effort in raising offspring. Young hatchlings were extremely vulnerable. Many predators could easily catch them. Large meat-eating dinosaurs, smaller carnivores, crocodilian relatives, mammals, and even other tyrannosaurs may have preyed upon young individuals. Remaining close to adults could greatly improve survival. If adults provided food, they may have brought pieces of meat back to the nest. Instead of carrying whole animals, they may have torn flesh into manageable pieces. Hatchlings with developing jaws would have found smaller pieces easier to swallow. The young probably learned many important skills by watching adults. Observing movements, feeding habits, warning signals, and reactions to danger could have helped them survive. Learning through observation is common among many intelligent animals today. As hatchlings grew into juveniles, their appetite increased rapidly. Growing bodies required large amounts of food to support expanding muscles, bones, and internal organs. Every successful meal contributed to steady development. Bone studies show that young tyrannosaurs experience periods of rapid growth. Scientists can examine thin slices of fossil bone under microscopes and observe growth rings similar to those found in tree trunks. These rings reveal that growth rates changed during different stages of life. Juveniles often experienced especially rapid increases in size before reaching adulthood. During early life, long legs allowed young tyrannosaurs to move quickly across their environment. Speed helped them escape danger and capture small prey. Their hunting style may have differed greatly from that of adults because their bodies were built differently during youth. Young tyrannosaurs probably occupied different ecological roles from mature adults. Instead of hunting giant plant-eaters, they likely focused on much smaller animals. This reduced competition between age groups living in the same area. As juveniles grew larger, they gradually shifted toward bigger prey. Social behaviour among young tyrannosaurs remains uncertain. Some scientists have suggested that juveniles may have spent time together, while others believe they were mostly solitary. Fossil discoveries showing several individuals together raise interesting possibilities, but the evidence is not yet complete enough to provide definite answers. Communication between parents and offspring may have included sounds, body movements, and scent. Hatchlings could have produced high-pitched calls to attract attention or signal hunger. Adults may have answered with deeper vocal sounds. Such communication would help family members remain aware of each other's location. Vision probably played an important role in recognizing parents and siblings. Tyrannosaurs had forward-facing eyes that provided good depth perception. Young animals may have followed the movements of adults through visual cues while remaining alert for danger. Smell also remained important throughout life. Hatchlings likely recognized familiar odors around the nest and detected approaching predators before seeing them. Adults with excellent smelling ability could locate food and perhaps recognize members of their own family group. Life around the nest demanded constant awareness. A moment of carelessness could allow predators to attack eggs or young animals. Adults needed to balance hunting, feeding themselves, protecting offspring, and maintaining their own strength. Not every egg hatched successfully. Some embryos died before completing development. Disease, poor nutrition, damage to the shell, flooding, temperature changes, or predators could all prevent successful hatching. Producing several eggs increased the likelihood that some offspring would survive despite these losses. Even after successful hatching, only a small percentage of young tyrannosaurs probably reached adulthood. Natural selection acted strongly during these early stages. Individuals with better health, quicker reactions, stronger bodies, and greater ability to avoid danger had higher chances of surviving. As juveniles entered later growth stages, their appearance changed steadily. Their skulls became deeper and stronger, their jaws widened, teeth became thicker and more powerful. Muscle attachment areas on the bones expanded, allowing greater biting force. Body weight increased dramatically over the years. Growth did not occur at the same speed throughout life. Very young hatchlings grew steadily. Juveniles then experienced especially rapid growth, before gradually slowing as adulthood approached. Scientists estimate that some tyrannosaurs gained several kilograms of body weight each day during their fastest growth periods. Hormonal changes guided development toward adulthood. Internal chemical signals controlled growth, reproduction, and changes in body shape. Eventually, the young animal reached sexual maturity and became capable of producing offspring of its own. Reaching reproductive age marked the beginning of another generation. Mature males searched for females during breeding seasons. Mature females produced eggs after successful mating. The cycle of nesting, incubation, hatching, growth, and reproduction then continued once again. Fossil discoveries continue expanding scientific understanding of dinosaur reproduction. New nesting sites, fossil eggs, embryos preserved inside shells, and microscopic bone studies provide valuable information. Every new specimen adds another piece to the history of tyrannosaurs and their families. Embryos preserved inside fossil eggs from other meat-eating dinosaurs have shown that developing young often rested with folded bodies before hatching. Scientists think tyrannosaur embryos probably adopted similar positions because closely related species shared many developmental features. The arrangement of blood vessels inside eggshells allowed oxygen to reach the growing embryo. Tiny openings in the shell balanced the need for breathing with the need to reduce water loss. Eggshell thickness varied enough to provide protection while still allowing successful hatching. Shell fragments found at fossil nesting sites sometimes show signs of successful hatching rather than destruction by predators. These fragments help scientists understand how young dinosaurs broke through the shell and left the nest. The study of fossilized growth inside bones has become one of the strongest tools for understanding dinosaur life histories. Microscopic examination reveals not only age but also periods of illness, slowed growth, recovery, and seasonal changes. These details allow researchers to reconstruct individual life stories from fossil remains. Some young tyrannosaurs may have travelled with adults after leaving the nest, gradually learning where to find food, water, and shelter. Others may have become independent relatively early. Different family groups could even have shown different behaviours depending on local environmental conditions. Changing seasons influenced reproduction. Eggs were likely laid during times when environmental conditions favoured survival. Warmer weather, increased food supplies, and stable nesting conditions would have improved the chances that hatchlings could find enough food after emerging from their eggs. Food availability affected reproductive success. Females that obtained enough nutrition before laying eggs could invest more resources in developing healthy embryos. Poor food supplies might reduce the number of eggs or lower the survival chances of developing young. Disease may also have affected reproduction. Infections, parasites, injuries, or nutritional deficiencies could interfere with successful breeding. Fossil bones occasionally preserve evidence of disease and injury, showing that tyrannosaurs sometimes survived serious health problems during life. Injuries sustained while defending nests may have occurred if adults fought predators attempting to steal eggs or attack hatchlings. Bite marks preserved on fossil bones show that violent encounters sometimes took place among large dinosaurs. Some healed injuries indicate that individuals survived such conflicts. The long period from egg to full-grown adult required patience and constant growth. Every stage brought new challenges, from surviving inside the egg to avoiding predators as a hatchling, finding enough food as a juvenile, and eventually becoming one of the largest land predators that ever lived. Throughout this life cycle, reproduction, nesting, incubation, hatching, growth, and parental behaviour formed the foundation that allowed tyrannosaurs to continue existing across countless generations during the closing part of the Age of Dinosaurs. About 66 million years ago, during the final part of the Cretaceous period, the world that Tyrannosaurus rex lived in changed forever. For millions of years before that time, dinosaurs had lived across the land. They had survived changing climates, rising and falling sea levels, volcanic activity, and many other natural events. Tyrannosaurus rex was one of the last and largest meat-eating dinosaurs to appear. It lived in western North America, where it hunted, scavenged, raised its young, and played an important part in the natural balance of its environment. It had become one of the most successful predators of its time. Even so, its great size, powerful body, and sharp senses could not protect it from a disaster that affected nearly every living thing on Earth. Scientists believed that the main event responsible for the extinction of Tyrannosaurus rex and many other kinds of life was the impact of a very large asteroid. An asteroid is a rocky object that travels around the Sun. Most asteroids remain in a region called the asteroid belt between the planets Mars and Jupiter. Some asteroids, however, leave their usual paths because of the pull of gravity from planets or because of collisions with other asteroids. When this happens, they may begin moving towards the inner part of the solar system. A very small number eventually cross Earth's path. If one of these objects strikes Earth, the results can be extremely serious. The asteroid that struck Earth at the end of the Cretaceous period is believed to have been about 10 kilometers wide. It traveled through space for a very long time before reaching Earth. Scientists estimate that it was moving at an extremely high speed when it entered Earth's atmosphere. As it rushed toward the surface, the air in front of it became very hot because of the great pressure created by its movement. Even before it touched the ground, the object carried an enormous amount of energy. The asteroid struck the area that is now part of the Yucatan Peninsula in present-day Mexico. At the time of the impact, this region was covered by shallow seas and coastal environments. The asteroid slammed into the ground with such force that it released more energy than billions of nuclear bombs exploding at the same time. The rock of Earth's crust was crushed, melted, and thrown high into the sky. A huge crater formed almost immediately. Today, this crater is known as the Chicxulub crater. Although much of it is buried beneath younger rocks and sediments, scientists have carefully studied it using drilling, maps, and other scientific methods. The first moments after the impact were filled with destruction. The force of the collision created an enormous explosion. Rock, dust, ash, and melted material were blasted far above the atmosphere. Huge pieces of rock landed hundreds and even thousands of kilometers away. Some of these pieces fell back to Earth while still extremely hot. Their return through the atmosphere produced additional heat. Forests and other plant-covered areas in many places may have caught fire because of the intense heat produced during this period. Powerful shock waves spread outward from the place where the asteroid struck. These waves moved through the ground and caused severe earthquakes over a wide area. The shaking damaged landscapes, changed river systems, and caused landslides. Large cracks formed in many places. The earthquakes may have continued for a long time as the Earth's crust adjusted after the impact. The impact also produced enormous ocean waves called tsunamis. These waves spread across nearby seas and then travelled into distant oceans. Coastal areas were flooded, plants, animals, and sediments were swept away. Evidence of these giant waves has been found in rock layers far from the impact site. These discoveries help scientists understand how far the effects of the impact reached. The explosion threw vast amounts of dust, tiny rock particles, sulfur-rich material, and water vapor into the atmosphere. Some of this material remained in the sky for a very long time. Instead of quickly falling back to the ground, it spread around the planet. Thick clouds of dust blocked much of the sunlight that normally reached Earth's surface. Days became much darker than usual. In some places, daylight may have looked more like deep twilight. Sunlight is necessary for green plants because they use it to make food through the process called photosynthesis. When sunlight became much weaker, many plants could no longer produce enough food to stay alive. Leaves died, growth slowed, and many plants eventually perished. Tiny plants living in lakes and oceans also suffered because they depended on sunlight in the same way. The loss of plants created serious problems for plant-eating animals. Dinosaurs that fed on leaves, seeds, fruits, and other plant material suddenly found less food available. Many became weak from hunger. Young animals were especially likely to die because they needed steady supplies of food to grow. Eggs and hatchlings also faced greater danger because their parents could not always find enough nourishment. As plant-eating dinosaurs disappeared, meat-eating dinosaurs also began to suffer. Tyrannosaurus rex depended on large animals for food. It hunted species such as Edmontosaurus, Triceratops, and other large dinosaurs that shared its environment. When these animals became fewer, Tyrannosaurus rex had increasing difficulty finding enough food. Even though it may have scavenged dead animals when possible, there were limits to how long this could support healthy populations. The food chain across the land began to break apart. Each living thing depended directly or indirectly on plants. Once plants disappeared in large numbers, the effects spread from one group of animals to another. Small animals disappeared first in many places, followed by larger animals. Populations became smaller until entire species vanished. The oceans also experienced severe losses. Tiny floating organisms called plankton were greatly affected by the lack of sunlight. Many kinds of plankton died, reducing the food available for fish, marine reptiles, shellfish, and many other sea creatures. Large parts of marine ecosystems collapsed. Some species survived, while many others became extinct. The atmosphere changed in several ways after the impact. Dust and tiny particles reduced sunlight, while gases released from crushed rocks entered the air. Sulfur compounds mixed with water vapor to form acids that later fell back to Earth as acid rain. Acid rain damaged forests, freshwater environments, and soils. Some plants were injured directly, while lakes and rivers became more difficult places for many living things to survive. Scientists believe that temperatures dropped sharply after the impact because so little sunlight reached the surface. This period of cooling may have lasted for months or even years. Cold weather placed additional stress on plants and animals that had already been weakened by hunger and darkness. Many reptiles depended on warm conditions to remain active. Long periods of cooler temperatures made survival even more difficult. Some researchers also think that after the dust finally settled, Earth's climate may have become warmer than before because of gases released into the atmosphere. If this happened, living things would have faced another period of environmental stress. Species that had barely survived the first changes now had to deal with new conditions. These repeated environmental changes reduced the chances of recovery for many forms of life. Tyrannosaurus rex did not disappear in a single day. Individual animals survived for some time after the asteroid struck. Some may have continued hunting in damaged forests and open plains where food was becoming scarce. Others probably wandered longer distances searching for prey. Older animals may have been stronger than younger ones, but even large adults could not survive without enough food. Young Tyrannosaurus rex faced even greater difficulties. Growing animals needed large amounts of food to develop healthy bones and muscles. Parents, if they cared for their young, would have struggled to provide enough nourishment. Eggs laid after the impact may have failed, because changing temperatures and damaged nesting areas reduced their chances of successful development. Many nests may have been destroyed by fires, floods, falling debris, or severe storms that followed the impact. Even nests that survived these dangers faced another problem. Newly hatched young depended on a healthy environment filled with small animals that they could eat while growing. As these smaller animals disappeared, the young predators lost important food sources. The extinction of Tyrannosaurus rex was part of a much larger event known as the Cretaceous Paleogene extinction. During this event, about 3/4 of all known species on Earth disappeared. Many groups of dinosaurs became completely extinct. Flying reptiles called pterosaurs also vanished. Large marine reptiles, including mosasaurs and plesiosaurs, disappeared from the oceans. Many kinds of ammonites and countless smaller organisms also became extinct. Not every living thing died. Many plants, animals, fungi, and microorganisms survived. Small mammals remained alive in many regions. Some birds also survived. Modern birds are the only dinosaurs that continue to exist today, because they descended from small feathered dinosaurs that survived the extinction event. Crocodilians, turtles, frogs, salamanders, snakes, lizards, and many fish also survived. Although some groups experienced heavy losses, scientists have spent many years studying why some animals survived while others disappeared. Body size may have been one important factor. Smaller animals usually required less food than larger ones. Many could hide underground, inside tree holes or beneath rocks. Some could eat seeds, insects, worms, or dead organic material that remained available even after plants became scarce. These flexible diets increased their chances of survival. Some mammals survived because they could eat many different kinds of food. Instead of depending on one specific source, they fed on insects, fruits, seeds, roots, and other materials whenever they were available. This flexibility helped them continue living during difficult times. After the extinction of the dinosaurs, mammals slowly spread into many environments that had once been dominated by large reptiles. Birds that survived may also have benefited from flexible diets and smaller body sizes. Some species could fly to areas where food remained available. Others fed on seeds that had been stored in the ground before the disaster. Seeds could remain alive for long periods even when sunlight was limited, allowing some plants to grow again once conditions improved. Fungi played an important role after the impact. They fed on dead plants and animals that covered large areas. Fossils show evidence that fungi became especially common for a period after the extinction event. This suggests that large amounts of dead organic material were available as ecosystems slowly recovered. The discovery of the Chicxulub crater provided one of the strongest pieces of evidence supporting the asteroid impact theory. Scientists first noticed unusual patterns in gravity measurements taken over the Yucatan Peninsula. Later studies using drilling equipment revealed shocked rocks, melted minerals, and other features that form only during extremely powerful impacts. Another important clue comes from a thin layer of clay found in rocks around the world. This clay contains unusually high amounts of the element iridium. Iridium is rare in Earth's crust, but is much more common in many asteroids. The worldwide presence of this iridium-rich layer suggests that material from the asteroid spread across the entire planet after the impact. Scientists have also found tiny glass-like spheres called tektites and other small melted particles within the same rock layer. These formed when rock was melted by the intense heat of the impact and later cooled while falling back to Earth. Their wide distribution provides further evidence that a giant impact occurred. Quartz crystals found in many places around the world also show signs of intense pressure. These are known as shocked quartz crystals. The special patterns inside these crystals form only under enormous pressure, such as that produced by large asteroid impacts or nuclear explosions. Their presence supports the idea that an extremely powerful collision took place. The fossil record also tells an important story. Rock layers below the impact boundary contain many kinds of dinosaur fossils, including Tyrannosaurus rex. Above the boundary, these fossils disappear. Instead, fossils of surviving animals and plants become more common. This sudden change in the fossil record matches the timing of the asteroid impact. Before scientists accepted the asteroid impact explanation, many other ideas were suggested. Some researchers believed that large volcanic eruptions alone caused the extinction. During the final part of the Cretaceous period, enormous volcanic eruptions occurred in what is now India. These eruptions produced the Deccan Traps, one of the largest volcanic regions on Earth. Volcanoes released lava, gases and ash into the atmosphere over long periods. Many scientists now think that volcanic activity may have weakened ecosystems before the asteroid struck. Changes in climate caused by volcanic gases could have placed stress on plants and animals. When the asteroid finally hit Earth, already weakened ecosystems were less able to recover. In this view, volcanic activity and the asteroid impact together shaped the final outcome, although the asteroid is considered the main cause of the extinction. Research continues because scientists constantly gather new evidence. Improved drilling methods, better computer models, and more detailed fossil discoveries help researchers understand exactly how events unfolded. Different studies examine how quickly darkness spread, how long temperatures remained low, how plants recovered, and how surviving animals adapted to the changing world. Computer models allow scientists to estimate the amount of dust and gases released by the impact. These models show how sunlight decreased, how temperatures changed, and how rainfall patterns shifted. Although different models produce slightly different results, they all show that the asteroid caused severe environmental disruption across the globe. Scientists also study fossil pollen and spores preserved in ancient rocks. These tiny remains reveal how plant communities changed before and after the impact. Many plant species disappeared suddenly, while others gradually returned as conditions improved. This evidence helps researchers reconstruct ancient forests and understand how ecosystems recovered. Charcoal preserved in rock layers indicates that widespread fires occurred after the impact. Burned plant material appears in many locations dating to the same period. This suggests that fires affected large areas, adding more stress to already damaged ecosystems. The extinction of Tyrannosaurus rex marked the end of one of the most famous groups of large land predators in Earth's history. For millions of years, tyrannosaurs had evolved into powerful hunters with strong jaws, sharp teeth, excellent eyesight, and well-developed senses. They occupied an important place in their ecosystems and influenced the populations of many other animals. Their disappearance left ecological spaces that were later filled by mammals and other surviving groups. Although Tyrannosaurus rex became extinct, its fossils remain one of the richest sources of information about the ancient world. Skeletons, teeth, footprints, bite marks, skin impressions, and fossilized droppings all provide clues about its biology and behavior. Every new discovery adds another piece to the story of how it lived and how it finally disappeared after the asteroid changed the course of Earth's history.